Hey, this is Jillian, and we are going to go over slope. We're going to start taking a look at some graphing, and here's the thing about graphs. Graphs are simply a picture of the words you have written. So I want you to imagine the word beautiful. You know how to spell it, B-E-A-U-T-I-F-U-L, beautiful. There we go. Right? That's beautiful. So one way you heard it, now you see it. Now here you're seeing the word beautiful. Now I want you to think of a photo or a piece of art that you think is beautiful, or even just a view of the sunset, or a pair of shoes you like, or a person's face who you think is beautiful, anything. That is merely a picture of what you think is beautiful. So sometimes beautiful will be expressed as a picture, and sometimes beautiful will be expressed in writing. That's exactly what graphs are. You may not think they're beautiful, but sometimes math is expressed in writing or algebra, and sometimes it is expressed in pictures or graphs. So let's take a look at some things that you may or may not know, and then we're going to go through some other stuff. So when a line is up to the right, it has a positive slope. And when a line is up to the left, it has a negative slope. When a line is steeper, think of skiing. If you skied down this hill, this is steeper than if you skied down this hill. So the steeper the hill, or the steeper the line, the bigger the slope number. So this, let's say, has a slope of 4, and this has a slope of, let's say, a half. 4 is bigger than a half. Steeper or less steep means a bigger number or a smaller number. Up to the right is positive numbers, up to the left is negative numbers. So, like with so many other things in math, positive and negative don't mean big or small, they mean direction. Okay, this is up to the right, positive direction. This is up to the left, negative direction. Now with respect to slope and algebra, as opposed to slope and graphing, the pictures, let's take a look at what some of the algebra says. So sometimes we look at slope. Slope is the letter M, small m, not big M. Big M is for midpoint. Small m is for slope. Don't ask me why. I have no idea. I'm sure Google can tell you why, but I can't. Anyway, so M is slope, small m, and slope is, let me just write this here, is also your rise over your run. So if you have a point here, and you rise a certain amount, and then you run a certain amount to get back onto the line. So you start on the line, you finish on the line, and you rise and run to get back on the line. That is your slope. Whatever the rise is divided by whatever the run is. Another way of looking at it is the change in y. Sometimes you've seen this delta, this triangle, it's D in Greek. Delta, or change in y, and change in x. So what's a change? Well, you know that if it's 4 o'clock, and then later on it's 7 o'clock, you know the change is 3 hours. That's what change is. The difference between where you were and where you are now, or where you went to. Another way of looking at slope, or calculating slope, is if you're given 2 points, the x and y value of the first point and the x and y value of the second point can be plugged into this little formula, y2 minus y1 over x2 minus x1, and that will also calculate the slope. These are all synonyms, right? Like pretty, beautiful, gorgeous, they're all synonyms. So, for example, let's take a look at doing this with these points. The way we write that we're taking the slope of between point A and B is we write M, and then sub, or lower, sub, that's why submarines go down in the water. Anything sub means down. So you put the M sub AB, so we know we're finding the slope between points A and B. So we would use, here is x1, y1 for the first point, and here is x2, y2 for the second point. So now we're just simply going to plug it into the formula. y2, which is 1, minus y2 minus y1, so minus 2, right, minus 2, over x2 minus x1. Now let's simplify this. This is 1 minus minus 2, and we know two minuses always make a plus, always. So we have, this is 1 plus 2, and this is minus 4 minus 3 is minus 7, and then that's 3 over 7, and the negative goes in front or in the numerator, as we've talked about before. If we want to find the slope, now hold on a second. Let me talk about what this looks like on a graph. So what this looks like on a graph is, if you have a graph and you're going to, hang on one sec, I'm going to just take a look here for a second at some graph paper. So we know our graphs always have a y with an arrow and an x with an arrow, and then some scaling. It just has to be like 1, 1, so you know what the scaling on the y and the x-axis is. You don't have to do each one at all whatsoever. And so now, if we have this slope, let's say we're told that there is a point 3, 1 that is on our line, and we need to draw a line with this slope. We will go, we know it's rise over run, so we're going to rise 3, 1, 2, 3, and then we're going to go left because the slope is negative, up and then left. So from here we go from this point, we go up 3, and then we go left 7. 1, 2, 3, 4, 5, 6, 7, and then you'll connect the dots. And that is a line, arrows at the end of your line, with slope being negative 3 over 7. Okay? Now let's take a look. They didn't ask us to do that. I'm just showing you what this looks like in a graph and what it looks like here. Actually, I just made up this point, 1, 3, 1. I could have used the point 3, negative 2. That would have been a better example. Okay, now let's do it for this. Here we've got, we always start with writing this out, y2 minus y1 over x2 minus x1. I'm telling you right now, if you get, what did I do? If you get lazy and you don't write it out, it is so likely you're going to make silly mistakes. It's really, I mean, you know, when somebody, if you were going to go into business and someone says to you, I run a multi-million-dollar business doing exactly what you want to do and you don't know anything about it, I'll help you. Do you think that it's a good idea to listen to what they have to say? Of course. So if somebody knows their math better than you do and they're letting you know how to avoid making mistakes, listen to them. Do what they recommend. Okay, I hope all that makes sense. So now I'm going to do, this is again x1, y1, x2, y2. Write it here or don't. You'll do these questions, you'll know. You know what, when I write it out it helps me or it doesn't, and then you do whatever makes sense for you. So y2 is a half, y1 is negative 3 over 2, and then we have x2 is 5 over 6, and x1 is 3 over 4. Lots of fractions. Okay, let's deal with this. So here we have 1 half plus 3 halves. So you can probably write this faster than I can. 1 half plus 3 halves over, and then here we have to find a common denominator. Here we didn't have to, of course, because it was already common. So what's common with 4 and 6? 12, right. So if this is going to be 12, and this is going to be 12, what did we multiply this by to get 12? 2. So then we have to multiply the top by 2. What did we multiply 4 by to get 12? 3. So now we have to multiply the numerator by 3. Okay, so now what do we have? I'm going to go up here. So now we have 4 over 2 divided by 1 over 12. Now, 4 over 2 reduces to 2. But before I even do that, when you have a fraction divided by a fraction, I want you to do this and write it out like this. A fraction divided by a fraction. And then the next step will be to flip that to multiply and flip that. And now you have some reducing to do. So you can reduce that to be 2 over 1. You can reduce that to be 6 over 1. It really doesn't matter. Any numerator to any denominator when you're multiplying fractions can be reduced. I'll say that again. Any numerator to any denominator can be reduced when you're multiplying fractions. So here I'm going to just make that 2 over 1. And now I've got 2 times 12 is 24, and 1 times 1 is 1. So the answer is 24. So the slope of this line is 24. That's a big number. It's going to be really steep. Because remember, 24 in a fraction is 24 over 1. So that means you're going to go from here up 24 and then over 1. It's going to be really steep.